Alrighty, ladies and gentlemen, it's time to graph some logs.
Logs!
That's Miss Folling in the hizzy. Yeah! Alright, so once again we got our handy-dandy T-chart, where we got our x's, our y's, and we'll have our little bit of work right here. Y equals log base 2 of x. Okay. So let's see here. We got to pick some points, and I'm going to help you strategically pick some points. Remember back to radicals when we tried to get like perfect squares with like 0, 1, 4, 9, so on and so forth? Where there's fancy numbers like that in this situation too, but they do change based on your base. Based on your base. That was awesome. Okay. Well, since it's base 2, we're going to be picking numbers based off of that. One that we're going to always pick will be x being 1. And I'll tell you why. If you had log base 2 of 1, 2 to what power gives you 1? Well, that would be 0. 2 to the 0 power gets you 1. So log base 2 of 1 is 0. There's a nice ordered pair. Excellent. Now the next one, let's see here. It's log base 2. So what we're going to do is we're going to choose 2 for x as well. Log base 2 of 2. Well, log base 2 of 2 means 2 to what power gives you 2? Well, that would be 2 to the first. Excellent. So then our output is 1. Now let's think, what's our next one going to be? Well, think 2 to a power. Well, let's do 2 squared then, I guess. That'd be 4, right? So if we have log base 2 of 4, 2 to what power gives you 4? Well, that would be 2. And we could go like that all day, every day.
All day.
Mmm.
That's a reference to Schmidt on New Girl.
New Girl. All right, so we've got 1, 0 right there. Oh, yeah. That's a terrible point, but, we're going to go with it. It's more of like a scribbly point. That's okay. Next one we've got is 2, 1. Woo. Then we've got 4, 2. That's cool, man. Yeah. Now, one thing we know about logs is that you cannot take the log of a negative number, meaning our x right here can never be negative. So basically what we have is a vertical asymptote at x equals 0. It's going to get really close to that, but it will never actually get to 0 or become negative. So that helps shape our graph. Now logs are they are inverse functions of our exponential functions. And we're going to see that here in just a sec. So what I can do is I can make my graph, and I can actually add a few more numbers if we'd like. My next point is going to end up being right around here, and then getting even closer and closer. So, if we did the T-chart with that, we could. We don't necessarily have to right now, but that's where those values are going to be going. And then I've got this. Woo! Fun stuff right there. Nice. Alrighty, so that's our log base 2 of x. Now we can graph its inverse, and if we remember back to inverses, you just switch the x and y. Like if you're writing the inverse of a function, you switch x and y, solve for y. We're basically just switching our x's and y's. So if one of our points is 1, 0, our new point is 0, 1. So this red one is going to be our inverse. Okay? If our next point was 2, 1, now it's going to be 1, 2. If our next point was 4, 2, now it's going to be 2, 4. Okay. And the same thing would happen over here. It'd actually start coming down, and our asymptote will be at y equals 0, which we remember back from exponential functions, because you totally remember everything that you learn. Alrighty. So then, if I connect the dots, there's my exponential function. So what's happening is it's actually reflected, and you'll see this written sometimes, it's reflected along this line, or about this line, okay, which is y equals x. It's reflected across that line, where the x and the y coordinates change. But that just shows, okay, if you have log base 2 of x, its inverse will be an exponential function. So we've got an exponential function here, and we've got a log function here. They are inverses of each other, and you can see that on the graph. Keep in mind, we're not always going to necessarily ask you to graph its inverse as well. If I ask you to graph y equals log base 2 of x, it would just be this blue one right here with its asymptote right here. That would be it. All right?